السلام عليكم ورحمة الله وبركاته. طلابي الأعزاء. In this video إن شاء الله we'll compute limit algebraically indeterminate using factorizing. Let's go. Finding the limit by factorizing. Evaluate limit x squared minus 1 over 1 minus x as x approach to 1. Now we'll direct substitution or substitute x by 1. We'll get x squared limit x squared minus 1 as x approach to 1 over limit 1 minus x as x approach to 1. We can't apply theorem 3.1. Why? Because limit 1 minus x equals 0 as x approach to 1 equals 0. It's a denominator, so it names determinate. Determinate means 0 over 0. So we can try algebraic simplification for the expression to get a cancellation. Numerator is difference between two squares. So remember that a squared minus b squared equal a minus b times a plus b, and c a plus or minus c b equals c a plus or minus b. This is the highest common factor. So in the denominator we use, in the numerator we use difference between two squares, so x minus 1 times x plus 1 over 2 cancel x minus 1 with x minus 1. In the denominator we have 1 minus x, so we'll get common factor negative 1 to get x minus 1. So we can cancel x minus 1 with x minus 1. We'll get finally limit x plus 1 over negative 1 as x approach to 1 equal. We can now direct substitution x by 1. 1 plus 1, 2. 2 divided by negative 1 equal negative 2. Okay. Next. We have now two other examples. Evaluate limit x squared minus x minus 6 over x minus 3 as x approach to 3. By direct substitution, we'll get 0 over 0 indeterminate. So we'll use factorizing to the numerator. Numerator is quadratic, so we're looking for two numbers. The product of two numbers get negative 6, and when we add them, we'll get negative 1. So we'll get x minus 3 times x plus 2 over x minus 3, because negative 3 times 2 equal negative 6. Negative 3 plus negative 2 equal negative 1, the coefficient of the middle term. Okay. Now we can cancel x minus 3 with x minus 3. We'll get finally the simplest form, limit x plus 2 as x approach to 3. Now we can substitute x by 3. 3 plus 2 equal 5, so limit equal 5. Other example, we have x limit x squared minus x minus 2 over x squared minus 4 as x approach to 2. When we use direct substitution, we'll get indeterminate value 0 over 0. Now we can use factorizing quadratic, the numerator quadratic and denominator difference between two squares. Now we're looking for two numbers. When multiply them, we'll get negative 2, and addition get negative 1. I'll give negative 1. So we'll get x minus 2, x plus 1. The denominator is difference between two squares, so a minus a minus b في a plus b, x minus 2, x plus 2. Now we can cancel x minus 2 with x minus 2. Finally, the simplest form is x plus 1 over x plus 2. Now we can use direct substitution without any problem. 2 plus 1 equal 3, 2 plus 2 equal 4, so the limit finally equal 3 over 4. Other example, in the left example, limit x squared minus x minus 6 over x cubed minus 27 as x approach to 3. Firstly, we use direct substitution. We will get 0 over 0 indeterminate. So we will use factorizing. The numerator is quadratic, but denominator is difference between two cubes. So remember that a cubed plus or minus b cubed equal, brackets has 2 terms and the other one 3 terms. The cube root of first term plus or minus cube root of second term, and the other brackets from small brackets, the square of first one, we use opposite sign, and the first one times second one, finally plus the second one squared. We'll use it in the denominator, so we will get x minus 3 x plus 2 over x minus 3 x squared plus 3 times x plus 3 squared 9. So we can cancel x minus 3 with x minus 3. We will get simplest form of limit as x approach to 3, x plus 2 over x squared plus 3x plus 9. Now we can direct substitute x by 3. 3 plus 2 equal 5. 3 squared 9. 3 times 3, 9 plus 9. 9 plus 9 plus 9, 27. Other example, same, but repeating with different numbers. Indeterminate. We can factorizing numerator and denominator. Now we can cancel x minus 2 with x minus 2. Finally, we can use direct substitution. Last slide. In this example, limit x times e power negative 2x plus 1 over x squared plus x as x approach to 0. Now we'll try direct substitute. We will get 0 over 0 because e power negative 2 times 0, 0 plus 1, 1, e power 1 times 0, 0. 0 squared plus 0 equals 0, so 0 over 0 indeterminate. Now we have two cancellation. In the denominator, we can use factorizing by common factor. The common factor in the denominator is x, so we'll get x times x common factor. So x squared divided by x equal x. Positive divided by positive, positive. X divided by x equal 1. So we can cancel x with x. Now we'll get the simplest form. Limit e power negative 2 plus 1, negative 2x plus 1 over x plus 1. Now we can use direct substitute x equals 0. So e power negative 2 times 0, 0 plus 1, 1. So we'll get in the numerator e. The denominator 0 plus 1, 1. E divided by 1 equal e. Okay. The last one. Limit 1 minus x, 1 minus e power 2x over 1 minus e power x as x approach to 0. By using direct substitution, we'll get 0 over 0 indeterminate. So we use we use factorizing now. We remember that e power 2x is the same e power x squared. So we can use difference between two squares in the numerator, we'll get, remember this rule, this factorizing kind, difference between two squares. So we'll get 1 minus e power x times 1 plus e power x over 1 minus e power x. Now we can cancel 1 minus e power x over 1 minus e power x. We'll cancel it. Finally, we'll get limit 1 plus e power x as x approach to 0. Now we can direct substitute x by 0. We'll get 1 plus e power 0. E power 0 equal 1. So 1 plus 1 equal 2. This is the final example. I hope you write inshallah, and we'll meet inshallah in the next video. We can use now conjugate inshallah. I hope you okay. Thank you.